So next, let's discuss the dielectric polarization and reduced electric field. So what do you mean by polarization? First, let's discuss about dielectric polarization. So for that, consider two parallel conducting plates having plus charge and minus charge. So here we have two plates, one is positively charged plate and another one is negatively charged plate. Now, introduce a dielectric slab in between the plates. So here we have an electric field. We have introduced a dielectric slab in that electric field. That electric field points from positive plate to negative plate. And this is our external electric field. Okay. Next, we have introduced a dielectric slab. And under the influence of this external electric field E0, the molecules inside the dielectric will be aligned in a definite manner. So the molecules will be aligned like this. The negative end of the molecule will be attracted towards the positive plate, whereas the positive charge of the molecule will be attracted towards the negative plate. So all the molecules inside the dielectric will be aligned in this manner. All the negative charges will be accumulated here and all the positive charges will be accumulated near to the negative end of the plate. Here we just consider this pair of positive and negative charges. These are two equal and opposite charges. They cancel each other. Then we have a set of negative charges here and a set of positive charges on this end of the dielectric. So when a dielectric is introduced in between the plates in the presence of an external field, what happens? Two opposite charges are induced on the two opposite faces of dielectric. So here negative charges are induced on this face of dielectric and positive charges are induced on this face of the dielectric. So two equal and opposite charges are induced on two opposite faces of dielectric under the influence of this external field E0. This phenomenon is known as polarization. So polarization of a dielectric is the process of inducing equal and opposite charges on the two opposite faces of dielectric, and here a electric field is produced inside the dielectric and that will be along this direction. And this is the induced electric field, and let it be EP. Okay. And it is just opposite to the externally applied electric field E0. Okay. So what is the induced electric field EP is opposite to the external electric field E0. So what will be our net field? Net field will be E0 plus EP. And we know EP is opposite to E0, so we can just put a minus sign here. So the net field will be E0 minus EP. Since electric field is a vector, we can put the vector sign here. So this is our net electric field, E net. Okay, so what happens to the net electric field? Net electric field is reduced. It is not E0 plus EP, it is E0 minus EP. So the net electric field is reduced. Okay, so when a dielectric slab is introduced between two oppositely charged conducting plates, the net electric field is reduced. And if electric field is reduced, naturally the potential will be reduced, right? Because V is equal to potential, V is equal to electric field into distance between the plates. So if electric field is reduced, potential is reduced, and if potential is reduced, as per this equation, capacitance is equal to Q by V. When potential is reduced, capacitance is increased. Okay, so this happens when a dielectric field or when a dielectric slab is introduced in between the oppositely charged plates. What happens? The net electric field is reduced, potential increases, and the net electric field is reduced, potential is reduced, and the capacitance increases. So when a dielectric slab is introduced in between the plates, a dipole moment is also developed inside the dielectric, and the direction of that dipole moment is from negative to positive charge. And this dipole moment induced per unit volume of the dielectric is also called as polarization. So polarization can be defined by two ways. Polarization is the process of inducing equal and opposite charges on the opposite faces of the dielectric. Also, polarization is the dipole moment induced per unit volume of the dielectric. Okay, and also this dipole moment is directly proportional to the electric field E. Okay, and this proportionality symbol is removed by adding a constant. The constant that we are adding here is chi. This symbol is read as chi. Chi suffix E into electric field. And this chi E is known as electrical susceptibility. It is known as electrical susceptibility. Electrical susceptibility. Okay, so the dipole moment induced is proportional to electric field, and this dipole moment is equal to chi E into electric field E. So the proportionality symbol is removed by adding this constant, and this constant chi E is known as electric susceptibility. Electrical susceptibility. Okay, then what is chi E from this expression? From this expression, chi E is equal to dipole moment P by E. And this E is the net electric field. Okay, it is not the external electric field, it is our net electric field. Right? And if E net is equal to 1, what will be chi? Chi E? Chi E will be equal to dipole moment P. Okay, so if electric field is 1, that means when unit electric field is applied across the dielectric, the electrical susceptibility will be equal to the dipole moment developed in it. So this is very important relationship, that is dipole moment P is equal to chi E into E net. Okay. Also, we have studied our dielectric constant K is equal to epsilon by epsilon naught. Right? Similarly, we have one more relation, that is dielectric constant K is equal to applied electric field E0 by the net electric field E net. And we know that this relation, this ratio epsilon by epsilon naught is nothing but our relative permittivity. Right? Okay. So E0 by E net, that means external electric field by net electric field, is also known as the relative permittivity. This ratio is also equal to our relative permittivity. Okay. Now, for dielectrics, this net electric field is reduced. We had just seen that the net electric field of dielectric is reduced due to that induced electric field. So if net electric field is reduced, K will increase. So K will be greater than 1 for dielectrics. The dielectric constant will be greater than 1 for dielectrics. For free space, what will be the value of K? For free space, this E net and E0 will be equal. Okay, for free space, this E0 and E net will be equal. Why? Because no dielectric is introduced between the plates. If it is free space, only air will be there in between the plates. So no induced electric field will be there to reduce that field. So the net electric field will be equal to the external field itself. So the E net and E0 will be equal. So the ratio will be equal to 1. So the ratio K will be equal to 1 for free space. Okay. And for conductors, for conductors, what will be the ratio? For conductors, K will be infinity. Why? Because you know, for a conductor, inside the conductor, the electric field is 0. The net electric field is 0 inside the conductor. Charges will be there only on the surface of the conductor. So what will be K? K is equal to E0 by 0. Anything by 0 will be infinity. So this ratio K will be infinity for conductors. Okay. So this is the value of K for different situations. So for dielectrics, K will be greater than 1. And if it is free space, K will be equal to 1. And for conductors, K will be equal to infinity. And for K, we have two ratios, epsilon by epsilon naught and also E0 by E net, where E0 is the externally applied field and E net is the net field. Okay. What is the summary? Polarization is the dipole moment induced per unit volume of the dielectric. Also, it is the process of inducing equal and opposite charges on the opposite faces of dielectric. That's all for today's session. With this, I am concluding our second chapter, electrostatic potential and capacitance. Next session, we will start with a new chapter, that is current electricity. So children, notes and YouTube video based on the topic have been uploaded. Please go through that. Learn the notes and then attend the test seriously. We will meet in the next session. Till then, take care, stay home, stay safe. Thank you.